So this is the first video in Unit 2, Perception. We're going to look at what sensation and perception are, and also start to introduce a few ideas about visual illusions as well. So firstly, sensation. Sensation is all the information that's processed by our five senses. So that's the physical stimulation of our sense receptors and all our different cells, so our hearing, sight, smell, all of those being stimulated by the environment. So for example, it might be rays of light hitting the retina in your eye or sound waves hitting your eardrum. This light and vision, the sound, are all examples of sensation. Perception, on the other hand, is how your brain organizes and interprets this sensory information, so we give it some form of meaning. So for example, the brain needs to interpret what our eyes see. So if we see a chair, for example, we use all our past experience to work out what it is and what it's used for. That would be an example of perception. It's our brain using that sensory information to give it meaning. So if we were to look at the difference between them, sensation is the information from the world around us that we get from all those different sense organs, whereas perception is how we organize, interpret and make sense of that information. And you can see that key word there, whereas, in red. That's so important when we're answering psychology questions that ask us about a difference. We give what one of them is, we say whereas, and then we state what the other thing is as well. So regarding visual illusions, in our next lesson we're going to go through all of these different illusions. You don't need to know what they are yet, but there are a few key things that could help you to understand and work out why they work. So the first thing is the concept of size constancy. So if you think about it, as someone starts to walk towards you, they appear to grow in size, even though you know they're not actually growing. So the rule of size constancy is it allows us to understand things that are in the distance are not really as small as they look. So it might be as you're up in an aeroplane and you look down, you know the houses are tiny, the cars are tiny, but you know they're not actually that size. So that would be us applying the rule of constancy. We understand that things in the distance are not really as small as they actually look. We've also got something called misinterpreted depth cues, and that's going to help us to explain some of the different visual illusions that can trick our brain. So depth cues are things that help us perceive distance or how far away something is. And once we've worked out something's in the distance, our brain uses that rule of size constancy that we just spoke about, and the things get scaled up to look normal size. So for example, when you see your friend in the distance, you know it's not a tiny version of them. That it's actually your friend full size, but just far away in the distance. But sometimes your brain gets fooled into thinking that distance is there when it's not. So your brain applies the rule of size constancy when it shouldn't really do that. And sometimes this is why we misinterpret distance in an image. So you may think something's far away, and therefore your brain sort of increases the size of it. It scales up that image. And it shouldn't really do that sometimes, because something may not actually be further away than it is. So your brain sort of gets tricked. And that's what we're going to look at next lesson when we start looking at all these different visual illusions. We've also got ambiguity. This is when there's two possible interpretations and the brain can't really decide which one to choose. So we've got Necker's cube there, and we've got whether you see a duck or a rabbit in that image to the right. And finally, we have the principle of fiction. So this is where you see something in an image that's not really there. So for example, on this image on the right, the image suggests something is there when actually that top triangle isn't there at all.